Welcome again, guys. Now in this video, let's solve some questions related to marginal utility for a quasi-linear utility function. Suppose our utility function is equal to 2 ln of x plus y, which is non-linear in x but linear in y. So now let's find out the marginal utility for x and the marginal utility for y. The marginal utility for x is equal to the partial derivative of utility with respect to x. The partial derivative of utility with respect to x. And now it's equal to 2 multiplied by the derivative of ln of x is equal to 1 divided by x. So it's equal to 2 divided by x. So then the marginal utility of x is equal to 2 over x. 2 over x. This is the marginal utility of x. So now let's find out the marginal utility of y. MUy, which is the partial derivative of utility with respect to y this time. So then the partial derivative of this utility function with respect to y is just simply 1. It's just simply 1. So it means the marginal utility of y is just a fixed number, which is 1. As you see, in the case of quasi-linear utility function, marginal utility in case of linear good is just fixed and equal to the coefficients of that linear good. As you see, the coefficient of y is equal to just 1 here, then the marginal utility of y is 1. But it's non-linear, or in the case of non-linear good, the marginal utility of that good is not fixed. But it rather depends on how much of that good we already have. As you see here, this utility function is non-linear in x, but linear in y. So the marginal utility of y is just a fixed number, which is the coefficient of y. But the marginal utility of x is not just a fixed number, but it depends on how much x already we have. So this is the difference between the marginal utility that we have as quasi-linear utility function and also other types of utility function, which is in the case of quasi-linear utility function, the marginal utility of nonlinear good depends on how much of that goods we already have in our consumption bundle. But the marginal utility of linear good is just fixed number and is equal to the coefficients of that linear good in our consumption bundle or in our consumption or in our utility function. So now let's solve another question for the quasi-linear utility function. Example number 7. Example number 7. In example number 7, our utility u of x of y is equal to, for example, x plus y to the power of 1 over 2. But this time, this utility function is linear in case of x, but non-linear in case of y. So let's have some other coefficients also. 2x, 3y. 2x, 3y. Then the marginal utility of x is equal to the partial derivative of utility with respect to x, and it just simply is equal to 2. Just simply is equal to 2. But the marginal utility of y, is equal to the partial derivative of utility with respect to y this time. Then it's equal to 3 multiplied by 1 over 2, and this one multiplied by y, 1 over 2 minus 1. Then the marginal utility of y is equal to 3 divided by 2, y to the power of 1 over 2 minus 1 will become minus 1 over 2. Minus 1 over 2. As you see here, the marginal utility of x, which is a linear good, is just fixed number, which is equal to the coefficient of x. But the marginal utility of y, which is non-linear good in this quasi-linear utility function, it depends on how much y good we already have in our consumption bundle. So this is 2 examples related to quasi-linear utility function. In the first case, our utility function was non-linear for x but linear for y, but in the second case it's linear for x but non-linear for y. So hope you enjoyed this video, and again, please don't forget to subscribe my YouTube channel and hit the like button and write down your comment below. If you have any question, just write your question. I will solve the questions right away for you with producing another video. See you guys.